All right, so this video is going to go through this loops worksheet number 2. All right, so we want to be able to write out the value of num for each iteration of the loop, the output, and then draw a logic model here. So the value of num here is 64 because it originally is 64. So 64 is greater than 7, so it prints 64. Then it does 64 divided by equals 2, which is basically num is equal to num divided by 2, which is 64 divided by 2 is 32. 32 is greater than 7, so it prints 32. 32 divided by 2 is 16. 16 is greater than 7, so it prints 16. Then 16 divided by 2 is 8. 8 is greater than 7, so it prints 8. And then 8 divided by 2 is 4. And 4 is not greater than 7, so it leaves the loop. Okay, so if we wanted to draw this out, for those of you that like visuals, we could say num equals 64. That's what it originally is. And then we get to this while loop, which is a diamond. Statements are in boxes, okay? So it would be num is greater than 7. Okay, and then what happens is it does the s.o.p. It prints num. Yeah, maybe I'll write that out and then draw the box around it. Okay, and then it does num divided by equals 2. Okay, and then it comes back up and it's at the beginning of the loop. Okay, and again I'm gonna have to close out probably each of these as I scroll down. Okay, next up we've got I is equal to 8. 8 is greater than 1, so we print 8. Okay, and it's not a print line, it's a print, so it's going to stay on one line. So then it subtracts 2 from 8, so it becomes 6. 6 is greater than 2, so it prints 6. Then it becomes 4. 4 is greater than 1, or yeah. 6 minus 2 is 4. 4 is greater than 1, so it prints 4. And then we subtract 2, becomes 2. 2 is greater than 1, so we print 2. And then I becomes 0. Is 0 greater than 1? Nope. So you're finished with that. And if we do the loop, or if we do the logic model, we've got int I equals 8. Okay, and it comes down here, and it does my does the Boolean condition I is greater than 1. Okay, and then it does the s.o.p, and it does I plus equals, or sorry, does I plus blank space. Okay, and that's in a box. And then it does I minus equals 2. And then this one comes back up and does that loop right there. And then I don't know if you want to draw a line right there, or after this is done, it just goes down to the next part of the code. So anyway, that's 2. Let's go down to 3. Okay, so we've got the value of num is 5, and the value of num is 4. Is 5 greater than 4? Yes. And is num 4 less than 10? Yep. So it does num plus plus, so num becomes 6. Dum becomes num, so dum becomes 6. Excuse me. Okay, 6 is greater than 4 and 6 is less than 10. So we do 7 right here. And then we set dum to num, which is 7. 7 is greater than 4 and 7 is less than 10. So we do 8 and we add 1 to 7, becomes 8, and then we assign it, so it becomes 8. 8 is greater than 4 and 8 is less than 10. So we add 1 to 9, 8 becomes 9, and this is 9. 9 is greater than 4, 9 is less than 10, so we add 1 to the num, it becomes 10, and dum becomes 10. 10 is greater than 4, but 10 is not less than 10, so you're done. And so it prints right here 10-10. Okay, and our logic model looks something like this. Num equals 5, dum, whoops, I need to put a box around that, and dum equals 5, box around that, and then put an arrow, and my arrow comes down, and I've got my num is greater than 4 and dum is less than 10. Okay, and so then we go in here and we say num plus plus, and then we go dum equals num. Come back up here, and then if it doesn't, or once you're out of the loop, then it does s.o.p num plus a dash plus dum. Okay, so that's the logic model there for 3. Okay, 4, so num starts off at 0. I is 5. 5 is greater than 0. So if 5 modulus 2 equals 1, well, how many times does 2 go into 5? It goes in 2 with the remainder 1. So that is true. So we do num plus I. So num becomes 5 because 0 plus 5 is 5. And then what happens? We go up here, we subtract 1 from I, so I becomes 4. Okay, so now is 4 greater than 0? That's true. So if 4 modulus 2 equals 1, well, 4 modulus 2 is 0 because 2 goes into 4 2 times with the remainder of 0. So this does not get hit, and we subtract 1 from I, and I becomes 3. Is 3 greater than 0? Yes. So 2 goes into 3 1 times with a remainder of 1, so then we got to add these two to get 8. Does that make sense? So 5 plus 3 is 8. So we go back up, I becomes 2. Is 2 greater than 0? Yes. So 2 goes into 2 1 time with a remainder of 0, so we skip that and subtract 1 from I becomes 1, and then 1 modulus 2. Now remember what the rule is: if the left hand side is less than the right hand side, then we turn the left hand side. So 1 modulus 2 is 1, so then we got to add these two together. So you get 8 plus 1 is 9. And then I becomes 0. Is 0 greater than 0? Nope. So we're done. So we print what num was. The final value of num is 9. Okay, so our logic model would look something like this. So num equals 0. And then we've got our, we go down here, and we've got let's see here. I'm going to make this a little bit smaller. We've got I is greater than 0. So if that's true, we go this way. If it's false, we come down here and do the s.o.p num, prints the num. So, but if it's true, then we got to do ourselves an if statement where we got another right here. So we got I modulus 2 equals 1. So if this is true, then do num plus equals I. Okay. And let me think here, come up around here, we would do something like this here. Okay, and if it's false, we just come around here and go like that. Okay, so the whole time we do that. So if this is true, we run this. If this is false right here, we just go over here, nothing gets hit, and we just come back up around and then run our stuff again. Oops, you know what? And I even screwed that up. So let's do this. So we do this, and then we do I minus minus. So if this is false, we come this way, and we just run that. Okay, and then we do one thing that goes up here again. Sorry about that, I forgot that. But anyway, that's definitely how it is now. So you do this one first, and then you do that. So if this is true, you'd run that and then that. If it's false, then you just come over here and subtract 1 from I, and you go back around. So that gets you in your loop, and then when you're done, you do this one right here. So that's that. Okay. Looks like we got about 2 more. Alright, so we got num is 1, num2 is 1, num3 is 0. Okay. Alright, so we got 1, 1, 0. Is 0 less than 14? Yes. Ooh, so then we got 1 plus 2, 1 plus num1 plus num2 is 3, so that's 2. And then num1 is 2, num1 is 2, so that's 1. And num2 is 3, so that's 2. Num2 is 3. And then we print num3, which is 2. And a comma. Okay. We go back up. Is 2 less than 14? Yep. So then we do 1 plus 2, and that becomes 3. So that is 3. Then we got num1 is num2. So we do that right here is 2. And num2 is 3. So that becomes 3. Okay, then we print 3. So I'm just going to do it like this. I'm going to say 2, 3. Now this is what is printed at that point, okay, because it's a print statement. It's not 2 different lines here, it's just 1 line. but that's all right. So we go back up, and 3 is less than 14. So we do 1 plus 2. So 1 plus 2 is 5. And then num1 is 2. So that's 3. And num2 is 3. So that's 5. And then we print 2, 3, 5. We got that going, 2, 3, 5. Now let's just erase that. Okay. Okay, 5 is less than 14, so we've got to add 1 and 2 together. 3 and 5 is 8. Num1 becomes 5, and num2 becomes num2 becomes num3, which makes it 8. So then we print 2, 3, 5, 8. 8 is less than 14, so 5 and 8 is 13. Num1 becomes num2. So that is now 8. And 2 becomes 3, so 2 becomes 13. Okay, we add these two together, so sorry, then we print 2, 3, 5, 8, 13. Okay, so 1 and 2 become 21. 2 becomes, or 1 becomes 2, so that becomes 13. And 2 becomes 3, which is 21. And so we print 2, 3, 5, 8, 13, 21. And 21 is not less than 14, so we are done. Okay. So this one looks like this. We've got num1 equals 1. Num2 equals 1. And num3 equals 0. So there's my there. And then we got our while loop. So our while loop is what? Num3 is less than 14. Okay. And then we got a bunch of statements in here. So we got num3 equals num1 plus num2. Then we got num1 equals num2. Then we got num2 equals num3. Then we got s.o.p num3. All right, you get the point. I'm running out of camera room. So then once that's done, we come up and we go back to the top of this. All right, so again, sorry, the handwriting's bad, but I think you get the idea. Okay, so that's done. And last one here, 6. And by the way, I got all the answers down here, except I don't have the logic model stuff, so let's see here. Okay, this one's kind of a fun one. So I is 8. 8 is less than 10. So it prints time on shot clock. 8. And then we subtract 1, it becomes 7. 7 is less than 10, so time on shot clock, 7, and then we subtract 1 and becomes 6. 6 is less than 10, time on shot clock is 6. And you should notice that I will always be less than 10 here, so you got yourself an infinite loop. Okay. And that would look something like this. So int I equals 8. Come down here. Yet I is less than 10. If it's less than 10, you do your s.o.p time on shot clock plus I. Okay, that's your box, and then you come up and you do that. Ah, shoot. Sorry. I need to do this right here. I minus minus. So again, I kind of ran out of room there, but that's what your logic model looks like. So practice this on your own, and you know, then come to the movie and watch it if you or the video if you need help with it. But this should be pretty easy, and you should be able to work these out no problem. Make sure that you write this stuff down in kind of the format that I'm showing you. Almost like table format. I didn't put tables in here with lines and or with rows and columns and stuff, but you know, like this one, you can see, you know, it's in a column. You know, the I is in a column, and then the output's in a column, and so this is how you can keep it, you know, easy to follow in your head. Okay, so this video is done.